Hello everyone, and welcome to iCap Academy. Today, we're diving into something truly revolutionary, agentic systems.
Revolutionary sounds exciting, Sasha. What exactly makes an agentic system so groundbreaking?
It's a new way of computing. It leverages large language model, or LLM-based, agents to do the heavy lifting. Think of it as intelligent components working together.
So an LLM agent is more than just a chatbot, right?
Absolutely, Marina. Much more. An LLM agent takes a specific context, gets clear instructions, that's its prompt, uses an LLM, and then produces a structured output. It's defined by its prompt, a precise output structure, and the exact context it needs.
That structure sounds really important for reliability. And how do these individual agents form an agentic system?
Great question. An agentic system starts with an input, often from a user. Then, a sequence of agents, let's say A0 to A3, process it. They collaborate, passing information along. The magic happens when they achieve a goal together, sending a response back. They can also trigger side effects like updating a database or sending an email.
Side effects. So they're not just thinking, they're acting in the real world?
Precisely. This coordinated action is what makes them so powerful. Let's look at some examples. They fall into three types: conversational systems, batch AI workflows, and simulations, or simulacra.
Simulacra sounds like something out of science fiction.
It can be. In conversational systems, you have direct user interaction, like a call center agent, or an AI companion.
I can definitely see the customer service applications there. It's like a highly trained expert, but available 24/7.
Exactly. Then there are batch AI workflows. Think of processing insurance claims, analyzing call center recordings, or sifting through resumes. The agents work through large volumes of data non-interactively.
Wow. That could save so much human effort in mundane tasks. The efficiency must be incredible.
It is. And for simulacra, imagine agentic non-player characters in an adventure game. Or artificial people in an economic simulation, or even an interactive fictional world. They create dynamic, evolving scenarios.
That's incredible. So much more than prescripted behaviors. It feels like true artificial life emerging.
It's truly a leap forward. To appreciate this, let's briefly trace the evolution of LLM-based computing. It started with basic GPT, just predicting the next word. Then came instruction-tuned GPTs. You added instructions, and RLHF, or reinforcement learning with human feedback, made outputs preferred by people.
That made them much more useful for specific tasks, right?
Exactly. A huge step. But then came chain of thought. If you told an LLM to think step by step, the output became much better.
That's brilliant. It's like teaching it to reason, not just respond.
It was a crucial insight. Building on that, reflection emerged. The LLM would produce an output, then self-critique it, and loop back to improve.
Self-correction. That's almost human-like learning.
It leads directly to agentic systems. They explicitly specify reasoning, allow self-critique, and mix code with LLM work. And, importantly, they enable side effects, interacting with the real world.
So agentic systems are the culmination of all these advancements. It's like we've given LLMs both a brain and hands to act.
A perfect way to put it. Now, how do we actually build one? We specify 5 key components: agents, flow, side effects, also called tools, controller, and interface.
That sounds like a structured engineering approach, which makes sense for such complex systems.
Exactly. Each agent needs a clear prompt, output, and context structure. That's all about data definition. The flow defines how agents interact, whether it's an explicit graph or a router. Side effects are the tools they use, like API calls, combining data and code. The controller is the brain, implementing the flow and calling tools. That's mainly code. And the interface is how we interact, the user interface or API, also code.
It's a fantastic breakdown. It shows how structured thinking is key to taming this powerful technology.
Indeed. But here's a crucial point. Agentic systems are probabilistic. So, reliability engineering is absolutely vital.
Probabilistic? So it's not always 100%, correct? That raises a concern. How do we trust these systems then?
That's a very valid concern, Marina. We address this with a verifier agent. It asks, is this correct? We can verify an output repeatedly, until we get a difference of k between the number of correct and incorrect votes, either way. This iterative verification significantly improves reliability. The formula can be derived from the well-known gambler's ruin problem.
Can you explain this gambler's ruin problem and how it applies here?
Sure. Suppose a gambler has 10 coins, with the probability of winning another coin being p. He plays until he either loses all coins or wins 20. This is the chance of performing a correct verification 10 times before getting it wrong 10 times. That probability is as given by the formula shown, with k being 10.
So you build in checks and balances using the verifier many times. That's a clever way to handle uncertainty.
Yes, but there's a balance to be made. The probability of correctness p also depends on the complexity and size of the task. It goes down as the task gets bigger and more complex. At the same time, if you break a big problem into too many small tasks, say m tasks, the overall reliability, capital P, can decrease exponentially.
So too many cooks can spoil the broth, even with agents. It's about finding that sweet spot between breaking things down and keeping them reliable. Smaller tasks improve each verification step, but having too many verification steps can again mess things up.
Exactly. It's about balancing the number of tasks, m, and the number of verifications, k. It's a core engineering challenge. Speaking of flow, there are three main architectural patterns. The explicit flow, often with conditionals, is highly structured and predefined. Then there's the router pattern. A router dynamically decides which agent to execute next based on context.
A router sounds very smart and flexible. It's like a traffic controller for agents.
It is. It offers more adaptability. Finally, the blackboard architecture, a classical approach from good old-fashioned artificial intelligence. It has a shared read-write context, where agents contribute and a controller schedules them.
A blackboard? So agents can just see what needs to be done and jump in?
Precisely. They raise a hand when they have a contribution. It's highly flexible, great for complex, opportunistic problem solving. For instance, in a medical diagnostic system, different specialists, agents, could add their insights to a patient's case on the blackboard.
That's a powerful analogy. It shows how collaborative and dynamic these systems can be.
To bring this to life, imagine a pseudo-DB, pseudocode setup. We have a data model describing each agent and action. Things like its prompt, input, output schemas, and what comes next. Then, a controller's pseudocode orchestrates it. It initializes context, fetches the starting agent, and loops. If it's an LLM agent, it calls the LLM. If it's an action, it calls the URL. And it determines the next step based on the agent's definition or the context.
So this is how all the components come together practically. The controller really is the conductor of this agent orchestra.
Exactly. It brings the entire system to life. To summarize, agents are prompts plus context and routing. Agentic systems involve invoking these agents and continuously passing context. Reliability is key, engineered by balancing steps versus verifications. Ultimately, multiple agents make the reasoning process transparent and robust through verification.
What an incredible journey! From simple text generation to complex, reliable, and intelligent systems that can truly act in the world. The future with agentic systems feels incredibly bright and full of potential.
It truly is, Marina. Thank you for joining me today at iCap Academy.